Okay, grade 11s, we're continuing from yesterday, but we're going to really focus today on the domain and the range and doing a really careful job with that because I know how much you loved it. Okay, we've been asked to graph the parabola and list the transformations. I'm going to go backwards and list the transformations in English first and then graph it. So for the parabola y equals a half x minus 4 squared minus 2, I see three things going on. First of all, I see that it is vertically compressed. It's wider, factor 1/2. I also see that it has been moved to the right 4 and down 2. So I am going to draw my parabola in one step instead of a series of transformations. I have going to move my vertex to the right 4 and down 2. So here is my vertex. 4, -2. And I do a quick check to make sure that matches my equation. It opens upwards because my a value is a half, but it is vertically compressed factor 1/2. So instead of over 1 up 1, I'm going over 1 up a half. And instead of, back to the vertex, over 2 up 4, I go over 2 up 2 on both sides. So my parabola would look like that. Okay, A and B are done. It says, is this a relation or a function? Or is the relation a function? Yes, it is. Two reasons. Number one, it will pass the vertical line test. I can draw a vertical line anywhere on this graph, and it will only hit my graph in one place. It's going to go on forever like that and continue to get a little bit wider as it goes. Secondly, all parabolas are functions. Last question, it says, state the domain and the range. So the domain is the acceptable x values. My x values are all acceptable. I can put any value of x into that equation and I will not have a problem. I can also see by the graph that it gets wider and wider and wider forever. So all values of x are acceptable. I would write my domain as x is an element of the real numbers. My range. My range is the acceptable y values. If you have a look at the graph, you see that it goes up forever and ever, and it includes whole numbers, integers, and all the little bits in between. So y is a real number, but it doesn't go down forever and ever. So we write our range as y is a real number, but y has to be greater than or equal to a certain value. And that is always the second part of my vertex. Y is greater than or equal to -2. For the second one, we're going to determine the equation, but also the domain and the range. So my equation would be, I'm going to just skip A for a second, and look at the vertex. The vertex is 1, 7. So I need x subtract 1 to move it to the right, plus 7 to move it up. Then I'm going to check my step pattern. Instead of over 1, down 1, it's over 1, down 2. It's also upside down. So my a value is negative, and it is a factor of 2. I'm going to include my domain and my range. My domain is the acceptable x values. X goes on and on forever in a normal parabola. This one, however, has an ending spot right here and right here. So it doesn't go forever left and right. It has a smallest value to the left and a largest value to the right. So if I'm going to write my domain, I need to say x is a real number. However, there's a starting point and an ending point for this particular parabola. Negative 1.2, I'm estimating, less than or equal to x less than or equal to 3.2. So this is what I do when I'm looking for domain and range. I write the letter in the middle, the smaller one first, the larger one second. My range is my y values. Y is a real number. But this particular parabola does not go forever up and down. It has a lowest place, which is right here, and it has a highest place, right here. So my range goes from -3 up to a y value of 7. For this next one, we've been given a description to come up with the equation like we did yesterday. This one has a vertical expansion factor 4. It's like you grab it and pull it up, skinny. It is translated 5 to the left and 16 down. So my equation would be vertical expansion factor 4. It does not say it's upside down, so I'm going to assume my A is positive. It's translated 5 to the left, so that would be x plus 5, and 16 down, -16. From that information, we would like to try and determine the domain and the range. A normal parabola goes on and on forever, left and right. Just because you've moved it up or down, left or right, made it skinnier, doesn't change the fact that eventually it's going to go forever, left and right. So that would be the normal domain. The range, because it's opening upwards, would be y is a real number. Y is greater than or equal to, because it's opening upwards, -16. The y value of the vertex. To remind ourselves about the definitions, a function is a relation in which there is only one y value for every x value. You also have the vertical line test. Let's have a look at these 4 relations for a minute and see if they're a function or not. The first one, you could draw a vertical line and it will hit that relation in more than one spot. This is not a function. Second one, looks like it might be a quadratic, but it does a funky little thing at the end there. But I could draw a vertical line anywhere on that graph and it will only hit in one place. It is a function. Here's a relation that I could draw a vertical line anywhere and it only hits in one spot. It's a function. This is not a function. As a recall, the domain is the set of all possible x values. The range is the set of all possible y values. For most quadratics, your domain is all the real numbers, unless you have a specific diagram you're looking at or a real-world problem that has a limit on the domain. For most parabolas, you have a y value that's an element of the real numbers, but y would be greater than or equal to the y value of the vertex if it opens up. Here's a couple of domain and range things that we haven't looked at for a while. For this first graph, I'm asking you to write the domain and the range. The domain is the acceptable x values. There are only x values here, 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 and here. We're going to write them as a set. The x values are 1, 2, 3, you'll never guess, 4, and 5. I'm just reading from the graph. The range also only has 5 values. First point is a y value of 2. Second point is a y value of 4. Third is 7, 11, and 16. For the second one, we have 6 possible values for the domain and the range. The x values for the domain would be 1, 2, 3, 4, and 5. The y values are 1, 3. Your eyes are better than mine. We might disagree about 1 or 2 of those values. 10, and 14, and 21. Try the third one with a friend. Lastly, I have a line segment. The domain is the possible x values. We are looking left to right when we're looking at x values. Because it's continuous, not just dots, I'm going to write x can be a real number, all the little bits in between. And I see that the furthest place to the left is when x is -1. And I see the furthest place to the right is when x is 5. So I'm going to write my domain as x is an element of the real numbers. X lies between -1 and 5. My range is the up and down, the y values. It has all the in-between bits, not just dots, so y is a real number. And it goes from 0 up to 6. So y lies between 0 and 6. I'll do 2 of these, and you and your friend do another 2. The domain for this one is my left and right x values. This one does not go on and on forever. There's no arrowheads at the end. The furthest left, it appears to be, is -1. And the furthest right appears to be a 5. So my x value lies between -1 and 5. My range, this one does not go forever up and down. There's no arrowheads. But all the in-between bits, y is an element of the real numbers. The lowest y value is a -6. And the highest y value is a 3. So my y value lies between -6 and 3. The one directly below it, it's a line segment. It does not go forever left and right, but x is a real number. It's not just dots. The furthest to the left is 0, and the furthest to the right is 8. So x lies between 0 and 8. The range is the up and down values. Y is an element of the real numbers. It's continuous, not just a bunch of dots. The lowest place for y is -2, and the highest place for y is +2. Y lies between -2 and 2. Try the other 2 with your friend.